What is thermal blooming in Air Force directed energy weapons? Imagine a powerful beam of energy being directed towards a target with precision and accuracy. However, what happens when that beam encounters the atmosphere? This is where the phenomenon known as thermal blooming comes into play, particularly in the context of directed energy weapons utilized by the Air Force. Thermal blooming refers to the distortion of a laser beam as it travels through the air, primarily caused by variations in temperature and density within the atmosphere. As the directed energy weapon emits a high-energy laser, the beam interacts with air molecules, which can lead to scattering and absorption of the energy. This interaction is significantly influenced by factors such as humidity, temperature, and atmospheric pressure. When a laser beam passes through warmer air, it can create a gradient of temperature that causes the light to bend or spread out. This bending effect results in a decrease in the beam's intensity and focus as it reaches its intended target. The phenomenon can be particularly pronounced over long distances, where the effects of thermal blooming become more significant. In practical terms, thermal blooming can impact the effectiveness of directed energy weapons. The intended target may not receive the full energy of the beam due to this distortion, which can lead to reduced effectiveness in disabling or destroying the target. As a result, military strategists and engineers must account for thermal blooming when designing and deploying these advanced weapon systems. To mitigate the effects of thermal blooming, various techniques can be employed. One approach involves adjusting the wavelength of the laser, as certain wavelengths are less susceptible to atmospheric interference. Additionally, adaptive optics can be utilized to correct for distortions in real time, enhancing the precision of the beam as it travels through the atmosphere. Understanding thermal blooming is crucial for optimizing the performance of directed energy weapons. By addressing the challenges posed by this phenomenon, the Air Force can improve the accuracy and effectiveness of its advanced weaponry, ensuring that these systems remain reliable in various operational environments.